So human history is basically a story of us finding lazy ways to survive. We started with our muscles, figured out fire, and then we started burning buried dinosaur fossils, and we called it progress.
Yeah, we literally built our civilization on barbecue fumes. Then we split the atom, discovered that we could vaporize cities also, and said, nice, let's use this to boil some water now.
And each of these energy revolutions, like fire, fossil fuels, or nuclear, Oppenheimer, by the way, gave us a bigger punch, gave us more power. And now we're trying to crawl our way into renewables, hoping nuclear fusion finally works before the planet starts resembling a baked potato.
If we ever master planetary energy management, the next step is very obvious, right? We look up and say, all right, let's colonize our neighborhood. Like the
Yeah,
the stuff surrounding us, not Earth.
yeah, like the moon, like the planets beyond Earth,
Yeah,
including and especially Mars and beyond.
yeah,
Well, the first problem is that space is hard. Physics like hates you hard, like that hard. Basically, getting serious out there takes absurd amounts of energy. It's like a lot. Okay, but there's like a ray of hope. There's like the silver lining of every cloud because we live near the biggest nuclear reactor in the solar system, which is our sun. So literally our sun. So
yeah.
it's like a trillion nuclear bombs per second.
And it's just sitting there. So the obvious
Yeah.
question is,
Yeah.
why do we settle for something like as weak as solar panels when we can just take the whole star? Why are we thinking so small?
Yeah. Why are we waiting for the sun to give its light 8 minutes away? Like 8 minutes
Yeah,
doesn't like it takes 8 minutes, right? So why are we waiting for those 8 minutes and like letting the intensity reduce? And why are we
exactly.
staying it here? So why don't we just take the solar panels to the surface of the sun?
Yeah.
Enter the Dyson sphere. It's basically a structure that captures the sun's energy input, at least most of it, a significant fraction of it is what the idea is. It
100% efficient,
exactly. It
but
basically is
most
the
of it.
cosmic. Yeah, exactly. It's the cosmic equivalent of plugging the sun into a wall socket. So you like
Yeah,
gain its power. It's like a nuclear reactor. So it's like a sphere that encloses the sun. It's like a ball that encloses the sun in another ball as another ball.
yeah, but we're not talking about like just a giant, like solid shell around our sun that
Yeah,
would
exactly.
collapse, maybe drift, or might as well it might as well disintegrate like your group project the night before it is due. Like that
Yeah,
happened
everything falls apart,
to me at least. The realistic version of this idea that we're talking about is something called a Dyson swarm. And
It's like this. Yeah. Yeah.
yeah,
It's basically
it's
like drones,
yeah, trillions of
I guess, kind of.
independent, what we call as solar collectors are orbiting the sun and they're forming like a cloud of power harvesters. So just for like simplification purposes, you can imagine trillions of solar panels just around the sun, like forming something like a sphere.
Yeah.
They're not exactly
Yeah.
solar panels, but yeah,
Kind of like Saturn's rings, except if they were like a 3D sphere.
yeah, yeah,
And that essentially they form a full sphere around the sun. It's not one full structure, it's a grouping of smaller structures, kind of like how in like places they have like these huge drone shows. It's how each drone works together to be a part of that
yeah,
whole show.
yeah,
So
yeah.
that way. So there's a problem though. To build it, we'll need a lot of material. Okay, if you want to cover the entire sun, like most of the surface area, right, as a sphere, we need enough
Mm.
material to make 30 quadrillion satellites, each of them weighing about, I guess, okay, I'll just tell the total. It's 100 quintillion tons total. So yeah, step one's destroy Mercury, right? Because it's fine, right? It's like metal rich.
Hmm. Yeah,
It has low gravity and nobody's living there. So you just mine Mercury, refine the metal, and just railgun those satellites into orbit, right? 30 quadrillion of those.
yeah. It's that easy. Like, why aren't we already doing that?
Yeah,
And
why don't we already have multiple Dyson spheres,
yeah,
As in one around our sun, one around nearby suns, stars.
true. And each of those solar power collectors unfolds in space like you can say cosmic origami, and it collects sunlight from there. And then we can use that energy to make even more panels. It's basically like exponential growth if you've
Yeah,
studied it in
yeah,
mathematics. The power of compounding, even
exactly.
like put in simpler terms. So one becomes two, two becomes four, etc., etc., etc. 60 doublings later, we've basically wrapped the sun like an energy burrito.
That's a good way to put it for food lovers, which is
Yeah.
everyone, I guess. So let's assume we take like a very optimistic scenario where
Hmm.
optimistic as in like very chill scenario. We've only captured 1% of the sun's energy output. Okay.
Hmm.
Then humanity's entire energy problem would just simply vanish. It would just
No
disappear
shit.
off the
Yeah.
surface of the earth. Because like we have enough energy to do whatever we want. Because the sun's output is just that much. We
Yeah.
can do terraforming of planets, interstellar travel, mega projects, everything's on the table. Like everything's open to discussion. Possible now, once you have 1% of the sun's output.
Yeah, and we might not even be the first one to try it. Astronomers actually search for Dyson spheres, basically stars that look too dim for their temperature because something's harvesting their light. Like
Ooh, so
there could
natural
be,
Dyson spheres.
yeah,
Nice.
or if we have to consider something that we spoke about in episode 40, spoiler, check that out. Maybe some other intelligent life could also be harvesting
Right.
the power of their own star. It
Exactly. There
could be
might be a few
possible.
steps ahead of us.
Yeah, or a lot of steps, but yeah, you get the idea.
Yeah, they might be a type 1, type 2, or type 3, or whatever civilization, while we aren't even type 1 yet. Exactly.
Hmm.
So, point is, so far there's been nothing. No one, either no one's made one yet, or everyone who did got bored and they just moved to a better galaxy and they like found better ideas than just piddly Dyson spheres that give you a lot of energy from your sun. That's not enough for them. They like evolved to get better stuff. That's
And
it.
this
You know?
this really brings us to a very classical argument. Is it even possible? Or are Dyson spheres just like the black holes of wishful thinking? It's never going to happen, basically. Well,
Right. Speaking of black holes, though, one second, that's my favorite topic. Let's talk about the other energy obsession that physicists can't shut up about. Okay, it's information conservation, basically saving information, like how black holes eat up information. That is that idea.
yeah, the idea that information about matter falling into a black hole isn't lost, it's somehow encoded in the radiation of the black hole itself, or maybe in some cosmic USB drive.
Yeah, fair. I mean, it always felt more philosophical than physical to me. Like Heisenberg literally told us we can't know anything about a particle, right? You can't know everything about a particle. You can
Yeah.
either know like one or the other, like
Either position or momentum.
exactly. It's a Heisenberg uncertainty principle. So
Yeah.
if you never had the info in the first place, how can you lose it?
True, true, true. It's just like misplacing the money you never had. You can't destroy what doesn't exist, right? But physicists still treat this like a cosmic crime scene, you can say. They're all like, where did the
Like a
data go?
kidnapping, Yeah,
Huh?
data was kidnapped.
Yeah.
Compare that. Okay, now let's compare back to the sun, which is our original topic. We
Okay.
can
Okay.
reconstruct its origin, right? Supernova, debris, gas clouds, stellar evolution, all that kind of stuff.
Yeah.
Basically, like the Hertzsprung-Russell diagram, which is an HR diagram, it's basically like tells you the type of
Mm.
star a star is.
Yeah.
So, for example, our sun is a main sequence star. I've not written that, but it's a yellow dwarf, is what it's commonly known as in informal terms. So each star goes through its life cycle, right?
Yeah.
During stellar evolution. If you do that with
Hmm.
a black hole is like at the end of some stages of stellar evolutions.
Yeah.
But the
If
info
you're
behind it is impossible to get.
yeah, basically if your solar mass is about if the mass of your star is above like 40 solar masses or something, it
Mhm.
has a chance that it becomes a black hole. Like
Exactly.
that's one of the conditions for it.
Yeah. That to be precise, that is like that's what it is. Like if you want exact values.
Yeah, and if you basically try reconstructing the origin of a black hole, you can't do that because the info is literally gone, right? We just talked about
Right.
that. And when it comes to talking about all of that, a lot of people the uh, would be like in the am lost camp. Like, what's happening? Maybe the universe just doesn't care
They're very
about
confused and they're
your,
like, yeah, they
yeah,
lost the information.
yeah, the universe just doesn't care about your data integrity.
Your precious, precious data, your
Yeah.
databases. Meanwhile, let's not forget that we're debating how to store information while also imagining structures that could trap stars. We have our priorities. So let's just get back to Dyson spheres. Okay.
There's actually a very valid counterpoint. We probably don't have enough matter to build one.
I mean, yeah, even if you took all of Jupiter and turned it into construction material, it'd be like, I mean, most of Jupiter is like gas clouds, right? It's a gas giant, so it's not
Yeah.
that much physical solid matter, so we can't really use much of it, right? But even if you took Jupiter, because even Jupiter is just so small compared to the sun. I think the stat is that if you fit a million Earths, you can fit a million Earths into the sun,
Yeah,
right?
yeah, yeah.
It's
Something
just so
like that.
big.
Something like that. Yeah. Yeah.
That's just so big.
Yeah, even if you took all of Jupiter and you turned it to, say, construction material, I would say that it would still be like trying to wrap a whole basketball with a human eyeball. It's just not possible because
Bro, why
that's
would you pick a human eyeball? Just say a ping pong ball or something. Why
okay,
a
like
human eyeball?
a ping pong ball.
A
Sure.
golf ball. Anything is fine.
You get the ratio, right? The sun
Yeah.
is just too big to make a
Yeah.
sphere that far out. You need to literally dismantle multiple solar systems. And by then, you would already be an interstellar civilization and you don't even need the spheres anymore. But wait, to become an interstellar civilization, maybe you need to become a type 2 civilization at least, where you can harness the power of your own uh, star.
So are you saying it's kind of like the
You
analogy
see
of
the
if you
circle, like the
so
paradox.
yeah, so are you saying it's kind of like getting a job requires work experience, but work experience requires getting a job?
Basically,
So there is a loophole, but
y-
like there's always like outs to that. So it's kind of like it's a paradox, is what you're saying, right? So it's kind of like stealing all your neighbors' roofs to build one giant umbrella roof above your house, but you already control the weather. So there's no
what's
point.
the
Like, why are
point
you
of
doing it?
yeah, exactly.
Like,
Yeah.
I mean, unless you really want to, basically, you are making your neighbors all wet and you are like completely dry, like in torrential rainfall. I mean, it's like called being evil, but yeah.
And technically, if we start talking about it, the sun already has a Dyson sphere. Very natural, like a natural one.
Mhm.
It's outer layer basically. Half
Yeah.
of the sun's mass is in that envelope, and it's absorbing energy from the sun's core and it's radiating it out. And well, all that I can say is nature beat us to it.
As always, as always. Well, but humanity doesn't give up, right? That's the whole point. We are stubborn. So astronomers keep looking. One study actually searched for Dyson spheres by scanning for red, infrared heavy stars. Because the hypothesis or the theory is that a Dyson structure would absorb visible light and re-emit in infrared. So they're like, if there's a natural Dyson structure, maybe, or maybe an artificial one,
Yeah.
whatever. Point is, it will absorb the visible, it'll re-emit in infrared. So they're finding red infrared
Mm.
stars
Yeah, yeah.
that maybe they can find Dyson structures directly rather than searching for alien life or whatever.
Yeah,
Fast
but
talking.
no, one problem is that dust clouds do the exact same thing, and we have so many of them out in our
Yeah,
universe. They absorb starlight and re-emit it as infrared. So every potential alien megastructure could just turn out to be cosmic dust.
yeah, and it has turned out to be cosmic dust so many times for these astronomers, right? They're
Yeah,
like cosmic detectives that are constantly mistaking suit for civilization.
yeah. Still, I like to think that someone out there did pull it off. Like,
So you're saying you
don't
believe
you?
that there are
Yeah,
aliens?
yeah,
Maybe.
yeah. But it just seems like a very forward thinking and somewhat of like a very beautiful thought to think that someone has actually done it and harnessed the whole power of their own star.
Yeah, it might be a step that's necessary to take to be an interstellar species, interplanetary species, maybe.
Yeah, and if humanity ever does this, it'll mean that we can use our universe itself as a tool, not just something to survive in, but something to engineer as well.
Damn, that's deep. But at that point, maybe we should stop worrying about the information loss or the information paradox in black holes and start worrying about how to do our physics homework on time. Actually, like, we need to actually worry about what kinds of species builds one around a star. Like, as in, um, we need to know whether we can do it or no. We have to, like, figure it out.
Yeah.
How to evolve into a type 1, type 2, type 3 interplanetary, interspecies, whatever civilization. Like, we need to, like, build up. That's the goal.
Yeah. First get to type 1, then start
One step at a
from
time.
there.
One type at a
Because
time.
right now we're like type 0.75 or
Point
something
7, I
like
think,
that.
right?
Yeah,
0.6 to point 0.7, 6 to 7.
close to that. Yeah, yeah, yeah. Oh my
Yeah.
God, that meme. Okay, so we'll end on this note.
Yeah.
The meme 6.7, 0.6 to point
Of
0.7. Okay,
course. Of course.
sure. See
Anything
you guys in the
else?
next one. Peace.
Yeah. Peace out.